Hello, this is Nitin Dahad with the Times. I'm here at OCP 2025 at the Texas Instruments booth, talking to Chris Suchoski. And Chris, hello, how are you?
I'm doing great, Nitin. Thank you for having me.
Chris, you've got a role in a specific division of TI. Tell me what that role is.
I do, yes. So I have the privilege of running our data center systems engineering and marketing team. So our scope, our charter is to essentially map out the key industry trends our customers are navigating today over the next several years, and develop reference designs that we're showing here today, as well as help guide direction around product definition for future generation architectures.
Now, that's actually quite important because this is all about data centers. It has been for a couple of years at OCP. I think part of that has been looking at the trends, and the trends are very much around the open rack specifications and things like that, but just walk us through a little bit of the evolution from Gen 1 to Gen 4.
Yeah, absolutely. So for about a decade and a half, 2 decades, we lived in the Gen 1 era, where we had 12-volt bus bar. And we reached a breaking point, essentially, that caused us to transition from 12 volts to 48 volts.
Correct, yeah.
Which is the Gen 2 ecosystem. Gen 2 is still prolific today. However, we're quickly reaching this point where Gen 2 is starting to break, especially when we're talking about 1 megawatt racks.
Yeah.
Put in perspective,
Yeah.
1 megawatt at 48 volts would require roughly 200 kilograms of copper
Really?
to
Wow.
translate
Okay.
that
Yeah.
much current.
Yeah.
Exactly, it's incredible. And that's causing us to now consider transitioning to 800 volt DC or plus minus 400 volt DC, which is the Gen 3 ecosystem.
Right.
And even in that ecosystem, we're starting to think about how can we maximize the real estate in terms of computational density in a data center, which is now forcing us to start evaluating, what would Gen 4 look like?
Yeah.
What would centralization of AC-DC power conversion look like, of energy storage look like, so that you can totally maximize the available real estate for compute in the data center IT white space.
Okay, so you said we're at Gen 3 at the moment.
We are starting to, enter our foray into Gen 3. So on the very beginning of Gen 3, with the expectation that over the next 2 years, we'll start to see first Gen 3 platforms start to ramp.
Okay, I mean, we'll talk a little bit about later when we talk about 800 volts, but that's kind of that sort of transition there, isn't it? So we'll talk about that
Absolutely.
in a bit. And what are the big challenges, and then I think we can probably walk through some of this in terms of what your customers are seeing. Things are moving quite fast, and I think those challenges are also moving quite quickly as well.
Absolutely. So in terms of challenges, there's the timeline component, right? We need to move quickly. We need to match our customers' pace, right?
Yeah.
There's power density, right? We're talking about racks going from 15, 20 kilowatts to 150 kilowatts today to over a megawatt in the next couple of years.
Yeah.
So the challenge of how do you actually fit that much compute into a rack? How do you minimize the footprint that power components have to really free up space for more compute? And there's a challenge of thermals, right? How do you effectively get the heat out of these XPUs so that you can ensure your system is safe, reliable, robust for a decade of deployment?
Yeah, and I think there's that whole issue of all these power like spikes and whatever. So I think those are things that are to be managed as well, aren't they?
Yeah, absolutely. It's causing customers.
In terms of like the demand, workload demand, isn't it? Yeah.
Absolutely. Think about some of the transients that these XPUs are creating when there's heavy workloads. It's inventing new end equipments that hadn't existed before. I think the capacitive backup unit is an example of that, where you have so much power being consumed by these XPUs. It's literally invented a new end equipment that had not existed in past generation designs.
Yeah.
So basically a bank of supercapacitors just to maintain the bus bar, keep it at regulation, so that it can ride out those heavy transients and prevent the bus bar from dropping and the rest of the system from browning out, essentially.
Is that very difficult for your customers then to figure out how to manage all of this?
Absolutely. Yeah, absolutely.
So what kind of stuff do you do on the power management side?
Yeah, so I mean, my team, we're really looking at, what are those key challenges that we're trying to solve, and wanting to, leverage some of the experience we have in the automotive space and the grid infrastructure space, and apply that to the data center market. There's a lot of commonalities from a transient perspective as well as from a voltage domain perspective. So leveraging a lot of the past learnings is kind of a foundation for what we're now applying to the data center space.
And what are you showing? I mean, there's some of the new things you're showing here. I mean, what are you doing at OCP?
Yeah, absolutely. So what we're showing here, this is our Gen 3 power supply. This is taking 3-phase AC in at the input, and it is creating an 800 volt or plus minus 400 volt output at 30 kilowatts of power density.
Wow.
To put it in perspective, you would need 33 of these in parallel to support a 1 megawatt rack.
Got it. Okay.
Yeah.
and any particular innovations that we should be aware of?
Absolutely. So we're using what I consider to be a pretty novel control topology, specifically on the front end of this design. So we're using a 2-level flying cap PFC, using our C2000 digital controller, which you can see here. And on the secondary side, we're using a 2-level 3-phase LLC, which again, using our C2000 digital controller. So it's the latest and greatest from a C2000 perspective, latest and greatest from a isolated voltage current sensing perspective to deliver a solution that our customers can use as a starting point for any of the Gen 3 power supplies they'd be designing.
Now, there's this whole talk, I think we talked earlier about the transition to 800 volts. Every company this week has announced its solutions, working with NVIDIA and other companies for the 800 volt support. Tell me a little bit about that transition.
Absolutely. So, I mean, there's a massive impact in making this transition. So obviously, it affects what we're doing from a power supply perspective. It affects what we're doing from a hot swap perspective. Right? We need to ensure that as these compute trays are plugged in and removed from the IT racks, they're done so in a way that protects the very, very valuable IT equipment. So causing us to reinvent how we're protecting these circuits. So using what we're showing here actually is an isolated 800 volt or plus minus 400 volt DC hot swap controller design to do so in a way that allows, again, for these things to be safely removed and inserted back into the compute tray. And then now you have 800 volts, you need to step it down, right? You need to actually get a usable, workable voltage. So working on 800 volt DC-DC designs to demonstrate that you can use TI GaN components, TI digital controllers, isolation to develop or deliver a 48 volt, 54 volt, 12 volt, really any intermediate bus voltage our customers are looking for.
And now you've been at the show, there's a lot of excitement. What are the things you're picking up today at the show? What are the things that customers and prospects are saying to you?
Yeah, I mean, I think it's exciting. I'd say all the interest in really everything we're showing here. So it's clear that everyone is trying to solve these problems in parallel, which I think is the beauty of OCP, right? You've got a collaborative working group where there's a common body of standards that we're all working towards, to collaborate and define what these standards need to be for this open ecosystem. And it's clear that it's obviously not just us working on this, it's us, our peers, our collective customers that are trying to solve these problems in parallel. So I think there's a lot of excitement around this transition to 800 volts. I think I'm eager to learn from others in this space, figure out what kind of unique topologies they're proposing, what unique architectures they're proposing, and kind of just compare notes.
And what's coming next from TI?
What's coming next from TI? That's an excellent question. So stay tuned.
Well, Chris, thank you very much.
Yes, thank you, Dan. I appreciate it.
Thank you.